Okay, so I will switch into English. Let me quickly introduce yourself. My name is Stropek. I am from Leonding near Linz. I have a small company there. It is called Software Architects. And software as a service in cloud computing is what we do. So we are really focusing on helping customers to transition from on-premise software into the cloud using software as a service and cloud technology. On the one hand side, we help customers doing that transition. On the other hand, we are developing software as a service solutions ourselves that we run and market ourselves or that partners of ours market. Today, the topic is Go. I started looking into Go, I would say half a year ago. My interest was raised because I have been doing quite a lot of work using Docker. Maybe you are already familiar with Docker. I guess some of you already are. And Docker is written in Go. And I'm fascinated from Docker, and so I thought, hey, if the guys from Docker, they are building great software, and if they using Go, it has to be some kind of interesting software. And if you take a look at what Google does in general, they're using Go pretty frequently. So my interest was raised. I took a look at Go, and my first impression was rather strange because I took a look at the language, and a lot of features that I am used to from C#, from TypeScript and so on were missing. I thought, okay, maybe this is not the right thing for me, but then I accepted what they have in the box, and I accepted that there are some limitations, and I started just coding. And I found out that it is really nice. It is really nice because Go is a straightforward language. It's rather new, so it doesn't have a long history. You don't have a lot of clutter inside the language. It's pretty clear, it's pretty straightforward, and it's an opinionated language. So there aren't for every problem 16 different ways of solving them, but if you have one problem, there is typically one solution to the problem using this language. On the other hand, a lot of things that I was used to aren't there. Go does not have classes. Strange. I was afraid when I saw that. Hey, no object orientation, no classes, no inheritance, no polymorphism. How should I code? And then I saw, okay, they don't have exception handling. Really? Seriously? A programming language, a modern programming language without exception handling? They don't have generics. Really? No generics? No semicolons at the end of line. Okay, I could live with that. I was fine with that. But at the end of the day, this is what I ask you for. I know you all have a background in C# and TypeScript. Stay open for the next 1.5 hours and accept that some limitations are there, and I will show you how to overcome these limitations, and we will see at the end of these 1.5 hours, every one of you can decide whether it's an interesting road and whether you want to follow me or follow the Go community and whether you want to become a gopher yourself, okay? So what are we going to do? We're not going to take a look at any slides. I love learning a language by just trying it. So we are going to look at code. I have prepared, I think it is 7 levels if you want. We will start very simple with just hello world, and we will work our way up to a simple microservice embedded in a Docker container running in Azure and partly built by Azure DevOps in a pipeline in the cloud and all this stuff. Okay? So this is what we are going to do step by step. What if you want to recap what I'm going to, by the way, this is me. If you want to get in touch with me, just remember that URL, stropek.me, and if you scroll down here, you will see all the different nice logos. So if you want to link yourself up with me with Twitter, Xing, LinkedIn, or anything like that, it's very simple to find. Okay, let's close that one. If you want to recap what we are going to do in the next 1.5 hours, you should take a look at this GitHub repository. So if you follow me on Twitter or something like this, I will post this link on Twitter. But if you want to take out your cameras and take a picture, and then you have the GitHub repository. The whole source code is there. The Azure pipelines, the Docker files, all the things that I prepared for this talk today can be found in this GitHub repository. Okay? Everyone got the picture? I think so. Additionally, if everything works out correctly, you see it here, I'm recording this talk. So if the technology works, I will put the whole talk on YouTube, and this is your third way of recapping what I'm going to show you today. Good. Let's get started. First, if you want to start with a new programming language, one of the first things that you have to decide is which development environment. I'm here at a Microsoft developer group, so we need to have some kind of product with Visual Studio in its name, and I decided to go for Visual Studio Code. Visual Studio Code is one of the most widely used development environments when it comes to Go programming. There are others too, of course, you can look them up using Google or your favorite search engine, but I decided to go for Visual Studio Code. If you take a look at the extensions here, and you look for Go, you will see that there is an extension from Microsoft for enabling Go development in Visual Studio Code. And as we know, Visual Studio Code is available on all platforms. It's open source, so feel free to use it on Mac, Linux, or wherever you want to write code. If you install Go on your laptop, you will get a folder. Let me quickly show you that in the Explorer here. Comes up, and here it is. It's running here in my users directory, and there you have the Go root folder, and here is a source folder, and then you typically organize your sources by source, in this case GitHub, and here is my username, and down there I have a repository, so there is this repository, and this is the way how the files are lined up. Please make sure, if you want to get started with Go, to read the documentation pages about how to organize your source files according to the Go philosophy. You shouldn't put your files anywhere on your disk. You should really follow the ideas of how Go organizes its directory structure. I will not go into the details here. This is boring. You can look that up in the documentation. This shouldn't be a big problem here. Let's take a look at our first few lines of Go code. This is a typical Hello World application. It has a name, package name. You can import some other packages. In this case, I'm importing the FMT, the format package. And then you write a main function. If you ever wrote something like C++ or C#, you probably recognize that one. And then we have a print line statement, and it says hello world. Very, very simple. So if we go into that folder, let me show you how we do that. Good, here we are. Let me go into CMD here. If I want to run this thing, here we are. If I want to run this thing, I simply say go, run, and give it the folder name. It runs, and it will print hello world. This is one of the first thing so it really feels a little bit like let's say like TypeScript or Node, for instance. You are writing a little bit of source code and you are just running it. It feels like an interpreted language like JavaScript, but it isn't. In the background, the Go code is compiled to an executable, to a language and platform, not language, platform and CPU architecture specific binary code. We can see that if we just say go build. If we say go build, you will see here that we now got a single executable. And you know what? The first step how Go got me was when I saw, okay, I have a pretty decent application. I compile this stuff, and what do I get? A single executable. Not 350 DLLs spread over I don't know how many folders. Not a Node modules folder with 20,000 files in it just to run a simple application. A single executable. You can take this executable, you can run it on any Windows machine, you can run it on any Linux machine, not this executable, but you can compile to Linux. You can compile a 32-bit, a 64-bit application, just a single executable, statically linked. No DLLs, no libraries, just a single executable. That was new to me because I'm used to Node modules and a lot of C# DLLs and so on. But this is pretty nice. I can, for instance, run this guy now if I say that one, and it will say hello world. This works perfectly fine. If I want to compile, give me a second. If I want to compile for a different operating system, for instance, I can simply set an environment variable. I can simply say, let me copy that, set Go OS Linux, and then we'll run a Go build again. And then we will, on Windows, compile this thing, and we will get an executable that we can run on top of Linux. And it's statically linked. The only dependency that this stuff has is the Linux kernel. we will see later on that can run these applications without any additional operating system like Ubuntu or Debian or whatever on top of the Linux kernel. It just needs the Linux kernel, and that's it. We can even run a Docker from scratch with that. We don't need an OS if we don't want an OS. So it's very simple to package, very simple to deploy. And think of scenarios where you want to build microservices. I sometimes am annoyed of big base images consisting of hundreds of megabytes and then having to copy large amount of files into some Docker files and then having images with, I don't know, 100, 150 megs or even larger. You will see that with Docker, a typical size of a Docker image running a microservice maybe on top of the Alpine Linux kernel is, I don't know, 20 megabyte, 30 megabytes, something like this. And this is pretty awesome, because if you run something like this on Azure, your Azure bill will not be very high, because this is very resource friendly. Okay? There was a question.
So if there isn't a runtime like in the .NET framework, the imported frameworks or libraries are included to the exec?
Yes, there is a runtime. Go has a runtime, but the runtime doesn't mean that it needs to be installed. Everything is in this one package. If you start this package, you are running machine code. So this executable is not intermediate language which is then compiled by a runtime like in C# into machine language. This is machine language, and the runtime of Go, for instance the garbage collector and things like that, are inside of this executable compiled to machine language code. Okay? So there isn't any kind of magic DLL, everything is self-contained, and I don't need to install Go on the target system just to run it. Everything is in the box. Pardon? No just-in-time compilation. That's real machine language code, and therefore it's pretty fast in startup, and it's pretty resource friendly. Yeah, exactly. Yep.
How is it then if you, let's say, want to run it on different CPUs? Well, because basically this is like kind of like...
Yeah, absolutely. Absolutely, there is a second environment variable which is Go arc, and there you can specify which CPU architecture you want to target. You can even go one step further. You can compile Go into WebAssembly and then run Go in WebAssembly on any platform using Node.js or even in the browser. I have a sample in my GitHub repository that runs a Go executable compiled to WebAssembly inside the browser and accessing the functionality using JavaScript. You can, even if you compile it to WebAssembly, you can access the DOM, for instance. You can run assembly, of course, in Node.js if you want, but you don't need that. You can compile it to any kind of language. Essentially, in the background, it's using a C or C++ compiler to really generate the machine language. There is another interesting project which might be interesting for you if we are talking about compiler targets. It's called TinyGo. It's a flavor of Go, a little bit reduced functionality there, but the idea of TinyGo is to produce, well, as the name suggests, tiny executables, which can even run on very small systems. So if you build IoT devices, for instance, where you have hard constraints in terms of memory and CPU power and so on, take a look at the TinyGo project. I guess we would have to check, but I guess all the samples that you are going to see from me today could be compiled with TinyGo, and the result is really a very tiny executable that you can run on different platforms, including Raspberry Pi and so on. Check out just Google TinyGo, you will find the project. It's under really active development. Okay? Good. Now, this was Hello World, pretty simple. Now we know a little bit about the tooling. Let me quickly check my script here. Yeah, we had the run, which just compiles it in a temporary location and runs the files from there. Go build really generates the executable, and I showed you cross operating system build, so building a Linux executable on Windows, and the same is true the other way around. If you have a Linux machine, you can generate a Windows executable on your Linux machine without having the need to install Windows or Mac, or I think you got the point. So let me quickly exit here and go into CMD again, and good. Next one. Let's take, yeah, question. Absolutely.
How about iOS? Is it possible
Yes,
to compile
yes,
iOS
yes,
code?
yes.
Isn't there the same limitation we have with Xamarin, that the compiler always needs a Mac?
I don't know. I'm not a Mac developer. I don't possess a Mac. I have no idea. So if you want to know what you need in order to build Mac OS code and whether that's a problem, you have to Google that. I'm very sorry. I have to apologize. Mac is a kind of it's a part of the IT world that I'm ignoring, not because it's bad, but just because I have limited time and I don't have the possibilities to look into it. I'm sorry, I cannot answer this question. Okay, so let's take a look at modules. Now, what I did here, in order to show you a little bit more about the language, I created a library. This library is not a main package and it doesn't contain a main function. It just offers some functionality which we can use from outside. So let me tell you a little bit about the language features that we see here. I'm going to zoom in a little bit so you see it better. First, if you want to export things, you have to use uppercase letters. If something is in uppercase, it's exported. If it's in lowercase, it's not exported. That's the first thing. The other thing you see here, it's a function. It has some input values. It has some output values. You please recognize that we don't have semicolons at the end of the line. That is how Go works. And yeah, not that interesting. If I, for instance, would put parentheses here and save the file, I can remove them again, and in many situations it just removes the parentheses automatically. Okay, we have an add function, we have a subtract function, and here we see another very important basic concept of Go. Please check out that one. That is a return type which consists of two values. So we are returning something like a tuple, but this is not a tuple like in C#, where you have a separate type, a struct type of type value tuple, but this is really a native function of the programming language Go. You can just return multiple values from any function that you like. And there is a convention that you always return the error, if there could be an error, as the last argument of your result list. So in this case, I wrote a little bit of business logic that says, hey, if y is 0, we cannot divide by 0, we are going to return an error, as you can see it here. Error is an interface. Unfortunately, we have limited time, so we'll not go into the details about interfaces here, but I think as you are all experienced programmers, you know what an interface is. So we are generating an instance here with this error f functionality. It generates an error, an object that fulfills the error interface, and it contains just an error language, an error code. Okay? So this is very, very typical for Go, and you will see it in the standard functionalities too. Now let's write a unit test for that. Go contains a unit testing framework out of the box. Go contains a lot of things out of the box. It contains a linter out of the box. So for instance, if you mess up something here, let's do it like that. I remove the comment. Now I get a warning. The warning tells me, hey Rainer, you see, Go lint here. Hey Rainer, exported function should have a comment or should be unexported. You know what I did when I months ago wrote my first library? I thought, okay, where is the linter config file? I would like to disable this stuff because I'm just playing around and I want to write comments now. Guess what? It's an opinionated language. There is no linter config file. Live with it. Adhere to it. Or live with the warning. That's it. Okay? That's the idea. That's the philosophy of Go to a certain degree. That makes it very clear. If you are a Go developer in a large enterprise and you have a lot of people to manage, there is no discussion about linter configuration files. I have spent dozens of consulting days in my life where people just wanted to discuss with me whether a certain thing should be a warning or an error. It's simply not there in Go. So this idea of being opinionated and standardizing on a simple but powerful thing, powerful standard, is a core idea of Go, and therefore it's very interesting, especially for larger groups of developers, because you write the code today and your colleague has to maintain it. He will take a look at the code and he will feel immediately at home because, yeah, the code looks the same and it adheres to the same quality principles. Okay? Good. Let's add the comment again to make Go happy. And this is a unit test. Very simple. What you do is you are just writing, again, convention. You're just writing a file which has the name _test. And then you write function, which takes a pointer to a testing.t class, which then contains a function that you can call if the test failed. Looking for asserts or expectations in Jasmine and so on, not there. The Go team says, hey, we don't need that. You have an if statement. And we don't want to have overcomplicated things. There is an if statement. Check your conditions using an if statement, as you can see it here. And if something goes wrong, print out an error message. And this is what the testing tool will look into. You can run these tests from here, or if we go into the folder, you can just say go test. It will look up all the test files, it will run them, and it will tell you whether it passed or not. In my case, everything is fine. Let's mess something up. Let's do it like that, for instance. And if I run this test again, go test, it will fail. And it will tell me expected 42, got 41. This is the error message that I specified exactly here, exactly what I wanted to have. Good. Another interesting construct that you will see very frequently in Go is this if statement, where you have, please note the semicolon here, multiple elements in this if statement. So we have the assignment statement here. It's inside the if clause, and then we check the result in the same if clause. So we don't need to write that in a separate way. The idea is that the assignment and the check should be in a single line because logically they belong together. It's a single operation that I would like to do here. Okay? We will see later on some more practical examples where this is really important, that we have the possibility to tell the system that in one line. Okay, some additional tests. I think it's pretty simple, pretty obvious. Yeah. Good. Now if we want to run this thing and use it, I thought it would be nice to have a kind of CLI. Let me show you what I mean with that. I would like to say go run dot, that's the local directory, and then I can say 21 plus 21, and the result should be 42. Okay, works perfectly fine. If I mess something up, something like this, there should be an error, exactly, missing parameters. This is what we want to see. And yeah, I think you get the idea. Yeah, we can do something like this. It should also print an error, in this case, invalid argument. Yeah, looks good. So now let's take a look at the source code to learn some additional things about Go. In this example, I'm manually parsing the arguments that come into the Go program. There are more interesting packages like the flag package, which is especially thought for CLIs. And I added that example by purpose because I wanted to tell you what Go is really, really good for. And that's, on the one hand side, command line interfaces. If you want to build a CLI for a microservice, for instance, or for any kind of cloud solution, this is one of the applications where Go really shines. Think of Docker. Think of Kubernetes. The Docker CLI and many other CLIs have been written in Go. The only thing that Go has to do there is a powerful argument parsing thing, and then using an HTTP client in order to talk to a REST API, which fulfills the task somewhere on a remote server. So if you have something like that, Go is really a powerful tool here. And the second thing, on the server side, building microservices, building server-side microservices. So having a web server, spinning up a web server, adding some business logic and things like that, this is the second big application where Go really shines. And you will see both of them. And as you see here, it's part of the core language, of the core libraries, that you have this flag package, which is very good in parsing command line arguments. We will not use this package yet. We'll take a look at it in a few minutes. Now we will do it manually, because then I can show you some additional things here. Let's take a look at the code here. Let me introduce you to a good friend, now a good friend, because we will use it all over the place. It's the assign and declare, or declare and assign syntax. You know with which language I learned programming? Pascal. And this is the second thing where Go had me. When I saw this operator, I thought, oh my God, I have seen that 25 years ago. More than 25 years ago, I'm so old. When I learned Pascal, what this essentially does, it it's declaring the variable args and assigning a statement. You don't need to write var in front of it like in C#. You simply don't need to. If you would remove that, you could also take a look at what this stuff gives you back. This is a slice of string, you see it here, and what we could do is we could say var args, which is a slice of string, and then we could remove this operator here. 2 lines, we don't need 2 lines, so I will remove that again, because in 1 line it's really convenient. Slices. Are you familiar already? This is a Microsoft developer group. Many of you know C#, right? Are you familiar with C#7 and C#8 and the range operator in C#? I see some people nodding. This is new to C#, right? It's built into the language with Go. Go has slices all over the place. A slice is a kind of array, but it has not a fixed number of elements in it. You can add things to it, and you have powerful range operators. In this case, I'm telling the system, take the slice args, which is nothing like an array of or a slice of string, and then remove the first element. So start with the second element until the end. This is what this range operator does. If you know it from C#, then you know it here. Maybe you have asked yourself how the C# language designers came up with this nice range syntax. Guess what? They oriented themselves on Go, because Go had the slices all over the place, okay, from the very beginning. So now we have the arguments. We can check the length of the arguments. That's a built-in function. Then we can do some interesting things. Yeah, that's a very good example here. We use A2I. Again. The past reaches out to me. I started, the second language that I learned was C++. Can you remember how you convert an ASCII into integer in C++? Well, A2I is maybe something that you can remember. In this case, I'm just saying ASCII to integer, and I'm taking the first argument, which is essentially the second argument, but because we had the slice up there, we are now accessing the first argument as 0, okay? So that was maybe not clear. Let me show you that again. Here we are removing the first argument, which is the program name, and then we can access the first parameter with index 0. Get it? Okay? Good. This is a practical application of the functionality that this function here returns 2 arguments. We are not saying try catch. If we want to catch an error, we have to manually check the error. So the handle argument error here does nothing else than manually adding an if statement to check whether we have an error. Oh, I will scroll up a little bit so you can see it better. Get it? No try catch. We have to do it like that. And we can declare and assign both values in a single line. This is very common in Go. Well, the rest shouldn't be any problem, because if you take a look at that, it's a switch statement that you probably know from C# or TypeScript. You don't need a break, because Go automatically makes sure that you can only enter a single switch here, a single case here. Anything else? Yeah, we have here these placeholders. By the way, these placeholders are pretty intelligent. So if I, for instance, mess something up here, and if I say %d, and I save it, I will get a warning. I should get a warning. Yes, I get a warning that the argument 1 is of wrong type. So the compiler already takes a look. The tool which says go vet, it checks the structure of the code, whether there are logical mistakes in the code. In this case, it cannot be a number. D stands for decimal, it's a number. No, it is not a number, it's a string, and therefore I get a warning and I can fix that. I don't need to write a unit test for that or something like this. So it's pretty safe. Question?
Could you have like 2 cases together, like in C#? Like for the
fall through, you mean?
Not in the way that C# does it. But you will see a little bit later, in a few minutes, you will see a different kind of switch statement. The switch case statement in Go is way more powerful than you might now think it is. Give me another few minutes, and if at the end of the talk I didn't answer your question, then please get back to me, okay?
Can you ignore the errors?
Of course you can ignore the errors, absolutely. So if you say, hey, I'm not interested in this error, you just write something like this, and that's fine.
Okay, so, but that means that if you say panic, then that means like hold the engines and that completely stops the program. Or what does it mean?
No, no, that's not completely true. You mean this panic here?
Yeah.
Yeah, this panic has a very specific meaning in Go. The panic stops the so-called Go routine. We will talk about Go routines in a second. This is one of the most powerful tools that you have in Go, the so-called Go routines. If you are C# developers, you know tasks, right? Go routines are very similar to tasks, except they are much more efficient. For instance, Go routines, just one example, Go routines have a very small stack. That might be a problem because you might do some interesting calculations there, but the stack of Go routines can automatically grow and shrink depending on what you essentially need. So one of the things where Go is really good at, it's parallel programming, running thousands and thousands of tasks, Go routines, on a limited number of operating system threads. So the same programming model that you know from thread pool in C# or from tasks. Yeah? This is called a Go routine. And what panic essentially does, it's panicking from the Go routine. So it's not panicking and saying the whole program has to stop. There are other possibilities for that. This is just exiting the single Go routine. In our case, we only have one Go routine. We don't split it up currently. We'll see that later on. But this is just stopping the Go routine. You can also resume the execution later on. You can create so-called defers. So what you essentially do with a defer, you can write a function call. Somewhere in the middle of your algorithm, you could say here, you could say defer some functionality. And this defer statement will schedule the function call automatically at the end of the function that you are currently in. So if you allocate something and you need to make sure that it is freed again at the end of the routine, you just say defer, and this defer call will be automatically called when the routine is done. And these defer algorithms, they can resume from panics if they want. Please Google it if you want to know more about it. But the truth is, panic does not stop the entire application. It only stops the Go routine.
So let's say if I have a strong opinion that the program should terminate on uncaught exceptions.
Then you would not do it with panic. You would do it with a different tool, and you will see that tool in a second. Okay? Good. So what's to learn from that? Very powerful slicing. A trick that C# learned recently is built into the language from the very first day on. Next thing, error handling. Like that. We have switch cases and things like that. Yeah, I think the rest isn't that interesting. Okay, now let's go more into microservices. We want to have, at the end of the day, a microservice that we can run. Let me show you how we implement a very simple web server. My third example is a web server. I've created a folder here, client, and there we have a very powerful index.html. Imagine this is your great Angular application that you have built recently, Angular or Blazor or whatever you do. Now here, I have a very simple web server. It's really very simple. In real world, it wouldn't be that simple. And as you can see here, I also have an advanced web server. So this is just the next level. We are making our way step by step into the right direction. The first thing that I wanted to show you is the flag package here. In this example, I'm not manually parsing the arguments. The only thing that I have to do is I tell the system, hey, Docker, I have a flag, which is a command line flag. So it's just a command line argument. The shortcut is P. This is the default value, and this is the description of my argument. And then I just say flag parse. Okay? This flag parse now takes the arguments and fills my variables that you see here. Okay? So if I run this guy, let me show you what I mean. I can go here. I can simply say go run dot and say minus minus help. This is a flag that I don't need to specify. it's supported by Go out of the box. Let me do it like that. And you will see here, usage of blah, 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 blah. And here you see -p, port on which the service should listen. I didn't have to write that. It comes out of the box. And of course, this flag package is much more powerful if you take a closer look behind the scenes. Now, if we run this thing, for instance, go run dot and -p 8081, and oops, and now it would run on port 8081. Get the idea? No, okay. The Windows firewall.
Like does the what variable have?
You see it here, unsigned integer.
Okay.
It's an unsigned integer in that case. Okay, once we have the flag, the next thing that we have to do is we have to create a so-called MUX, a multiplexer, an HTTP multiplexer, which is essentially a kind of router. The multiplexer assigns URLs, paths, to functions. Let's take a look at the ping function. The ping function is a really trivial handler function for a multiplexer in Go. It takes two parameters. The request, from the request we could get out the URL, the query string and the query parameters and the path parameters and whatever we need, the request headers and whatever we want. And the response writer is, of course, as the name suggests, the guy which we can use to write the results. And in my case, I'm taking the string pong, Go is, everything in Go is UTF-8 encoded. That's essentially UTF-8 encoded string pong. And this is then typecasted to an array of bytes. Please note that array of bytes does not mean that every single index of this byte array is a single character, because it's UTF-8 encoded. A single character, if it's not standard ASCII, could consist of multiple bytes. That's important. In my case, Pong is really simple. It's only 4 bytes. So I'm really typecasting the UTF-8 string constant to a byte array, and I'm writing this byte array simply to the response writer. Okay? I'm not copying things here. It's just typecast what we do. And here we say, if the user specify /ping, please call this function, and this will write something. If you are a C# developer, or even better, if you are a Node developer, and you have ever taken a look at Express, for instance, or the HTTP server of Node, you will probably immediately find yourself at home, because yeah, it's pretty simple to use. We can also use anonymous functions if we want. I've done that here. As you can see here, echo, it's just a func. So I can write an inline function, an anonymous function directly into the handle. Up there we had a named function. And this is where you see how we can access the request. I'm just saying, hey, request URL, give me the query parameters and get the parameter called message. Then I'm checking whether the message is present. If it is, it's called echo. I'm just sending it back. And if it is not, I'm writing a header which says status bad request. Difficult? No. Very simple to read. Maybe I don't even would have to read that to you. If you take a look at the code, it's pretty obvious what it does. This is exactly what Go should fulfill. Of course there is IntelliSense. Yeah, of course. r.url.query, and you get all the nice thing, and then I say get, and here you see it works pretty well. Yeah. By the way, I didn't mention that. If you add, let me go back here to our, no, not that one. Oops. If I go back to the modules and I take a look at that one, this is the documentation standard in Go. This is not just a comment. It's really the comment which ends up in the documentation pages and which ends up in the IntelliSense. Even if you do something wrong, for instance, if you remove that one, you will get a warning because there are some opinions that every documentation line should start with the name of the member, because sometimes maybe you do a grep across your source code and you want to see which member is the documentation about. Unfortunately, it would be in the next line, so we don't know what this is all about. So this ends up in the IntelliSense. Good. Let's go back. We are nearly done, as you can see it here. The next one is, I thought it would be nice to additionally have a little file server. So what I do here, I say, hey, take the current directory, this is the current directory, add client here, and set up a file server, and also put it into, you see it here, the multiplexer. So I'm telling the system, whenever the user asks for /client/something, remove the /client and serve this one from this file server. Very simple to a static very similar to a static file middleware that you might already know from C#, from ASP.NET Core. Get the idea? And last but not least, we say listen and serve, and that's it. Listen and serve now starts the HTTP listener on a certain address, in our case the port that we specified, and we're giving it a so-called handler, and a multiplexer is a handler, and this multiplexer is simply caring for calling the correct function if an HTTP request comes in. And this gets back to your question. This is the one that you want to call if you would like to early terminate the entire program. Log.fatal really says, emergency exit, I am done, stop everything, it doesn't work.
But you need to request it then, if I understand correctly, that you kind of like crash the thing, or is it like...
No, this is exit.
Yeah,
Log
sure.
Fatal is...
Yeah, sure, but basically like if you have like unhandled exceptions in C# code, typically, or like...
There are no exceptions here.
Yeah, sure. But I mean, like in comparison, like if you in there you would just uncaught exceptions usually would then terminate the program, right?
Mm-hmm.
So how would you have something similar here then that if you have
it would terminate the program.
Okay.
Yeah. Yeah. We can take a look in the break in specific cases that you are interested in. Okay. So let's run this guy on port 8080. And let's take a look whether it works. Well, it definitely works, but I want to prove it to you. Let me open it up. The Windows firewall always complains because Go compiles, if you say go run, it compiles the code into a machine language code, into an executable somewhere in the temp folder, and it gets a new file every time you run it, and therefore it's a little bit annoying, but let's call ping, and it says pong. Nice. Let's call echo, and it says hello world. Nice. Let's call echo without a message. We get bad request. Looks good. And let's ask for the index.html file. This index.html file is the file that I've shown you here. Let's take a look if the static file middleware works. And yes, it works perfectly fine. So we have a very, very, very simple web server written in only a few lines of Go code. And if you know Node and if you know C#, you probably shouldn't have any problems with the code so far. Okay? Good? Good. This is not a real web service already, but now we are heading towards more complex things, which are really Go specific. And the first thing that I would like to show you as a kind of warm-up is a more advanced web server. Let's go into the advanced web server here. Let me show you what this advanced web server does before we take a look at the code. Go run. Oh, let me terminate this one. Yes, allow access. Come on. Come on. Good. So you can't read it here at the bottom of the screen, so I will move it up a little bit because this one is now important. If I say go run, it starts a very simple web server, which listens in this case again on port 8080, if I can remember correctly. Let's give it a second until, this is it. And the important difference now is if I press Control-C, so I'm terminating the process, I'm requesting the operating system to terminate my program, see what's happening here. It now says, shutting down the server gracefully stopped. This is what I wanted to have. I don't want the operating system to kill my web server. I want to perform some graceful shutdown routines. Maybe notify some clients via WebSocket that I'm now going away or something like this. Okay? Let's take a look how this works. A lot of the things are very similar, but we see if I zoom in a little bit, let's see if I can, I can do it No, let's do it like that. I can also draw here. There is one new thing here, and you have to understand this thing in order to understand why Go is so powerful. And this thing, what I'm interested in are these, essentially this one line here, this make chan pla. This is creating a channel. A channel is a way of communication between Go routines. Go routines, as I told you, a lot of you are C# developers, are just like tasks. Imagine in C# that you have one task and then you have another task. How can these two tasks talk to each other? Typically, you create what? Shared memory, right? You just create a variable and one task writes to that memory and the other task reads from that memory. What is your problem? Well, you need mutexes and semaphores, or you need thread-safe collections, or you need some kind of queuing mechanism which is thread-safe and things like that. And the Go language has a solution for that built in. These are the so-called channels. You can set up a channel, and this channel is type-safe. You can say this is a channel of integer, of string, or customer, of whatever. Okay? And then one Go routine can write to this channel, and the other Go routine can listen on that channel. And these channels are thread safe. You don't need to worry about any kind of mutexes or semaphores or whatever. And it's type safe. So in this case, we are setting up a channel of type os.signal, and signal, if we take a look, it's just an interface. We don't need to care that the OS package is built into Go. It's just abstracting away some operating system stuff. So in this case, it's just an operating system signal that we get. And we are creating such a channel, and we call this channel stop. The type of stop is a channel of signal. Then, in this case, I'm telling the system with another package here, the signal system, the signal functionality. It's part of the OS functionality. That if the system, if we receive an interrupt from the operating system, we want to notify our program through this channel that we created here. So we give the channel to the operating system and tell the operating system, send us a message through this channel if the user press Ctrl+C to terminate our application. Get it? Okay. Now I'm setting up the handler function and I'm doing some HTTP stuff. We already know that. It's the multiplexer here. And now comes the important part. The important part is here. This Go here is the magic to start the Go routine. Go, anonymous function, and please note that we are calling this anonymous function here. Go with the function means run this function on a separate Go routine. It's just like starting a task. C# task.run. Here, built into the language, Go function. That means separate Go routine. In this separate Go routine, I'm just setting up the web server. So this web server is now running in a separate Go routine. My application is not blocked. It keeps running from here on. Now the listen and serve does not block my main Go routine. It's running in a separate Go routine. So we're continuing the program. And take a look what we have here. This is another operator based on channel. We are saying here, stop until you receive a message through the channel called stop. It doesn't need to be called stop. So I now recognize that this is not a good name here, because the application, let's say it waits on this location until somebody sends a message into the channel stop. Get what I mean? This is similar to an event listener. To an event listener that is blocking and keeping your program from continuing. You can have channels where multiple people can write into. You can do a lot of interesting stuff with channels. We don't have the time for that today. I just want you to understand that channels are a really powerful thing when it comes to these Go routines. You have a question?
So more like, it would be not more like this, like more like a wait in that sense.
In Yeah, for this case, in C#, you would probably say task.run, and maybe here you would also have a task, and here you could await on that task.
So
Maybe.
Notify would actually be like gives you a task back, which will tell you when basically when
Yeah, it
something
could.
is completed, and then it would say
Yeah,
await.
yeah. Something like this. You will see in a few minutes that we can do much more interesting things with these channels. But in this example, you are right. Await would be a good way of solving that maybe in C#. Well, and if we receive the stop signal, the only thing that we do is we are calling the shutdown method, which is part of our server, as you can see it here, and therefore we are gracefully stopping our server. Okay? This is what we do here.
So how does that other task or this like Go routine that's basically on listening actually getting that message?
Yeah, good question. The question is, how does this other task gets it? You see, we are creating the server here. This listen and serves runs on this server, and we are sending the shutdown message to this server. So therefore, the shutdown message is magically transferred to this server. This server stops the listen and serve method, and it will return and continue with the print line once the listen and serve is completed. Yeah.
Okay, captured context in that sense.
Exactly. Good? Okay? Very good. So, I would like to do one more example, and then we'll do a short break. And maybe after the break, we'll come back to the final half hour, where we will then take a look more on the Docker and cloud and build stuff, okay? But I would like to, if it's okay, we are so deep into the language, and we just have two other examples more that hopefully are interesting. Now we are really writing a web API, and now it's getting really interesting. So, the web API, the first thing that we have in the web API, we need some kind of data model. In C#, you would typically write what classes. What would you do in TypeScript? You would create either classes or interfaces, something like this. In Go, you create structs. Go doesn't have classes, Go has structs. Structs are just, well, structures of members. And here you typically see a structure with an ID, a first name, a last name, and an address. The address is not an embedded structure. In this case, it's a pointer. It's a pointer to address, and address is just another struct, as you can see it here, and that's it, nothing special. The interesting thing, which is unique for Go, are these so-called tags. What you can essentially do with structs, you can add arbitrary key value pairs to any struct member. Okay? It's a little bit like attributes in C#, but they call it here tags. And there is one specific tag, as you can see here, which is called JSON. You just say, okay, what is the property for rendering this struct into JSON? And then the engine, the HTTP engine built into Go, is using reflection to take a look at the tags at runtime and knows what to do with these members in order to turn them into JSON. You could omit these tags here if you want, but then you would have to manually marshal around with some JSON stuff. But this is really convenient. This is typically, as you can see it here. Okay? So I can assign names, and I can assign other properties. Take a look at the documentation to fully understand what's here. And this is typical. If you want to transfer that in JSON, you would do it like that. If you do something like Google Protobuf or other things, many of these libraries use these tags in order to specify what to do with the structs. Yep.
The alignment here of the types and so
Yeah, it's beautiful. It's opinionated. If I save my file, it's auto-aligned. I don't have to do that. Let's go.
The linter will also show in running.
To be honest, I don't know, because Visual Studio Code will always reformat it automatically. There are also command line tools which you can use to reformat everything. I've never checked if I change that in Notepad++, whether I get a linter warning. I've never done that, but you should do it like that. And it's opinionated, as I told you. Now, next one. I've implemented, I have to zoom a little bit differently. Yeah, this is good. Please note, the function is valid. Now comes a new important thing for Go. Is valid on the left-hand side has this p star person. That means we are adding a function to a struct. We don't write the code here, but we write it down there, and with this p person, we are assigning is valid as a member function of the structure person. So if we have an instance of person, we can call this function with a dot. Person dot is valid.
So kind of like extension method.
Kind of like extension method, but this is the main functionality how you add a method. You can add a method to an interface, you can add a method to a struct, exactly like that. Okay? Oh, many questions, I see. Mm-hmm.
If you would add to the person a lowercase second name, would you be able to access it in the isValid function?
Yes, you are, but not outside of this file.
Okay.
Yes. No, that's not wrong. That's wrong what I said. Not outside of this package. It's local to the package. Yeah. If you have a lowercase member. Yeah, that's true. Can we add? Can I postpone the discussion a little bit? I would like to show you this example so that we.
Just one remark.
Remark.
You don't need a pointer here.
No, you don't. Thank you for pointing that out. Absolutely. You can also do it like that. You're absolutely right. Thank you for pointing that out. Yeah. Now, let's take a look at the switch statement here. The switch statement is now really different from what you know in C#. Take a look at the switch statement. Could you do that in C#? No, you don't.
You could you can do pattern matching.
You can do pattern matching, but you can't do something like this where you can add arbitrary combinations of things. You can write any kind of expression here, and if it's true, the system will enter the case statement. See? I can do whatever. I can do whatever I want here, essentially. So for error handling, this is really convenient. In this case, I'm just returning errors. So now let's take a look at how we do that in real life. Here I'm adding some people to a so-called slice. We talked about slices before. And then I'm using a different router here. I'm using a router which is very frequently used if you write microservices in Go. It's the Gorilla Max here. And what I do essentially is here, you see it here, it's a new handler function. I, for instance, have parameters. In this case, I'm also using a regular expression so that the router will check that this has to be a number and so on and so on. It's really a very convenient thing. Take a look at the router if you want to build a real powerful microservice. It's simply capable of doing much more interesting scenarios than the built-in router that comes out of the box that you have seen before. Okay? So this should look pretty familiar if you write your code in Node.js or in C#. This shouldn't be any problem. And then I have implemented the different methods. I don't think that we need to go into all the different things. There are some things that I would like to point out because they are unusual. For instance, this one. Many of you are C# developers. That's a for each statement. For each var item in people. Get it? But the nice thing is that the first thing also will give you an index. So I could say ix, and if I hover over ix, it will tell me it's an int. I get the best of the for and the for each loop in a single construct. And also the language designers of Go, they didn't invent two different words for the same thing, similar to JavaScript. So we have a for loop, and the for loop can do what we know from C# for each, and it can do what we know from for, and it can even combine both things in a single construct. Very useful. How often have you written a for each statement, and then in the middle of the function you came to the idea, oh, I need the current index where I'm in, and then you start creating a whatever? You don't need to do that here. It's done automatically. This is the range operator. What else do we have? Let's take a look. I'm doing a little bit of writing the results, and here I have another for loop. I don't think that I have anything new here. Well, this is nice. In this case, I need to cut out one element from a slice. As you can remember, a slice is an array. that can grow and shrink, and you have this nice range operators. Essentially what I do here, I have a slice of people, and I'm saying I found the index where the person is that I would like to delete. And in this case, I'm saying, give me the slice up until the index, but don't include the index. And then append this with the rest of the people with starting index +1. Get the idea? And with that, I get very efficiently a slice which contains everything except the element at index.
So does this allocate new memory? Or?
Not for the people themselves, but of course for the slice.
Okay.
Yeah. Mm-hmm.
And this is so robust that when I remove the last from the people, then it also brings back. It gives you
an empty slice. Okay. What you will get from there. Okay. This program has a very, very, very big problem. Every HTTP request that runs in my application runs in its own Go routine. So Go starts a Go routine for every incoming HTTP request. It's not like Node.js. Node.js is single-threaded. In C#, we get a separate task for every HTTP request, right? And Go works the same way. So here we have a big problem because these operations, they are not thread safe. So if you have many, many HTTP requests coming in, bad things will happen to our program, and we have to solve that. Okay, and that will be my last example that I'm going to show you, and then we go into the break. But do you get the general principle here? You're just setting up the router, and then you implement your functions or your handlers, and of course you can build libraries of these handlers, and you don't need to care about all the JSON stuff because it's built in. Good? Good. Now the last example for the language, and then we'll do a short break. Advanced Web API. What I did here is I created a file which I called cart.go. It's a shopping cart, but this time I would like to have a singleton shopping cart. One shopping cart. It's still in memory. I don't have the time to go into databases and things like that. It's still in memory, but I want to have a lot of Go routines for a lot of HTTP requests, but a single cart. And this cart should be thread safe. It should only exist one at a time. So what did I do? I have product, I have a cart item, something that is in the shopping cart, but please check what I also have. I have a bunch of structs, as you can see it here. Each of these structs represent an operation that I can apply to the shopping cart. And the interesting thing is that these operations have parameters. See it here. If I want to apply a coupon to reduce the prices, for instance, I have the coupon number here. And then I have a response channel. See it here? So the idea is if somebody from an HTTP handler would like to add something to the cart, he has to send me a message through a channel. And I will respond through the response channel to send back the result. Get the idea? So whenever we need to communicate between Go routines, we do that with channels. Let's see how this works. I will focus only on the very interesting stuff. This is not an interesting stuff. This is also not an interesting stuff. This is the interesting stuff. This is what I was looking for. You see, here I'm again using a select statement, but this time I'm using a select statement which is embedded in an endless for loop. In this endless for loop, I'm saying, for instance here, if I receive a message through the read channel, execute this code. If I receive a message through the update channel, execute this code. If I receive a message through the reset channel, execute this code. And now I think you got the idea, right? If we scroll down a little bit, we have a quit channel, which doesn't have any parameters. The only thing that it does, it's ending our Go routine, which cares for managing the shopping cart.
But if you don't get any message for a long time, the loop runs
Don't worry about that. Go is very efficient. It will recognize that and everything will be fine.
So no burning one CPU.
No, you are not burning a CPU for that. You are not. No, you are not. So how does the client look like? The client looks like that. Let's take a look, for instance, to this one, reset cart. Now this is a function which gets called when an incoming HTTP request was received, okay? This incoming HTTP request started a Go routine. The Go routine now executes this algorithm, and this algorithm, the first thing that it does, it creates a read cart operation, and it creates a channel, as you can see it here, through which it will receive the response. Then it uses the read cart operation that you see here and sends the reset message, as you can see it here. So it's sending this read cart operation to the cart channels. It's sending an operation of type read cart operation. And then it's waiting for the response. Get the idea? So we have a channel that the caller uses and it sends a message to the cart, and then it some kind of blocks. This is like an await statement here. It blocks the further execution. It's not blocking the execution. It's freeing the Go routine. That's absolutely, it's freeing the thread. It's really very much like await. But in our case, the important thing is that we don't only get an await, we really get a type safe channel, and we receive the message from the cart through this channel, and we will do the rest of the method once we received the message through the response channel. Do you get the idea, approximately? A little bit. So if we take a look at the cart here on the right-hand side, and if I scroll down a little bit, where is the reset? Here is the reset. So what's going to happen? The system starts a Go routine through the multiplexer and the server. Then we are creating this read cart operation on this side, and we are sending the read cart operation to the reset channel. This line here will make sure that this line is going to be triggered, because this line, check it here, waits on the same channel. You see it here and you see it here? They are waiting on the same channel. Then something magic is happening, generate cart. Whatever this does. Could write to a database, it could have fun. In our case, it's just executing some singleton data structures in memory. And then the result is sent to the response channel. And this line is now making sure, by the way, these algorithms are running in parallel until here, because this is now stopping. And this will continue because we send here something back through the response channel. Get the idea? And now the other one is continue to work. You got an approximate idea how this stuff works?
So how does it happen? What does it happen like if you have bombarded with several commands? Like how is this like some queuing involved then between them, or?
Absolutely. Channels can receive a lot of these messages, and channels can have a maximum amount of things they can hold or not. So these channels are automatically buffered, but you can also say, I only accept, I don't know, one message or two messages, and then the caller gets blocked until they have space again to send new things.
So this is more like this actor model programming, kind of like you have in Akka and Akka.NET, I believe they do have it, something like that.
I'm unfortunately not familiar with that, but there is something which you call the a blocking collection in the concurrent collections namespace of C# that does a similar thing if you want.
Yeah, basically, all these workflows. I don't know, but basically it's like...
The difference is that in C# these things are implemented in the framework, and here they are implemented in the language. This is a language construct. This is a first level construct inside of the Go language. Okay?
It was influenced by Erlang.
Yeah, I read about it. I've never programmed Erlang.
Because Joe Armstrong was sitting on the same table with Rob Pike, and they were discussing, they were implementing Golang, and they were discussing these kinds of problems, and then Joe Armstrong, one of the inventors of Erlang, told him about the actor model, and so it got into the language.
So it is actor model based?
Yes, it's almost like it. It's not exactly like it.
Okay.
Because in Erlang you don't have these strict types. It's typed in Erlang, but you don't have really types because of other properties of because it's in a VM and stuff like that. So it's very much different. Here you have types.
Yeah. Thank you very much for letting us know. I've never programmed Erlang before, so okay, very interesting input. I would say let's do a 10-minute break, right? It's now 5 minutes before it's 6:24, so let's continue at 6:35. That's okay?
I don't know how to.
Okay, let's switch to English again. Last 20 minutes or so, I would like to show you what we can do with Docker and containers, and what we can do with Azure DevOps and Go, and why Go is really great in that area. Let's first start with containers. I've written a small Docker file for you that is compiling our application into an executable, in this case a Linux executable, and then running it on top of Alpine Linux. So let's quickly take a look on this Docker file. The first thing is we use the existing Golang base image. This Golang base image is used to compile the code. We install the module that we use. By the way, I'm not using the new module system of Go for this example, just to keep things simple. If you want to take a look at real world Go, Go has its own module system where you can fix the version numbers of the components that you use. You have separate files for that. Take a look at that. I will not cover that in that presentation, so I keep it very simple. I just install the Gorilla Mux package here. And then I'm calling the Go build, which just runs the build on top of our simple web API. And this Docker file is a so-called multi-step Docker file. I'm not sure if you are all familiar with multi-step. Essentially what multi-step says, you have two different from clauses in a single Docker file. You can say the first one up here is used for building the application. So I'm building from the Go code to the executable inside of the Docker container, inside of the Docker file when using Docker build. The second part of the Docker file is really the image that I would like to create. This will be the image that I run in my data center, for instance. Okay? So there, I'm just using Alpine Linux as my basis. And please note that the building Docker file is marked as builder here. And down there in the copy statement, we reference the builder file up here. So let me scroll up a little bit so you see it better. I can't put everything on the same screen at the same time. Here, I'm saying, hey, what we have built up there, please copy it into the target. The target Docker image does not contain the tools that are necessary to build Docker files. It's just the executable that we have in it. And I'm calling the application, it's just called web because I specified the name here. I'm exposing it on port 8080 and that's it. Let's try that one. So let's go into the simple web server here. This is the simple web API and do a Docker build. Let's give it a name, Go Web, and it's the local directory. Let's go for it. I did it before I started this session, therefore it's pretty fast because it's cached. Okay? But this is exactly what you would do. Well, if you wouldn't have cached it, it would get some things from the internet, it will take 5-10 seconds, whatever. But now I have a Docker image, Go Web, and, images. And this is the important thing here. A single executable on Alpine Linux with a size of 17.8 megabyte. That's pretty awesome. No installed Go, no runtime, no DLLs, no nothing, just, 17 megabytes. Whatever we need to add is really part of our application. We don't need to add some fancy runtimes here. It just runs. We can even go one step further. You would probably not do that in real life, but it's an interesting experiment. What you can do is you can say, hey, forget about Alpine. Let's do a scratch. From scratch. From scratch means, let's do it like that so we see it more what we have changed. From scratch. From scratch means I'm creating a Docker container without any OS. You know how Docker works? Docker means you use the OS kernel from the host. So when we start a container, we are not really starting up a new operating system, but we are using the kernel of the host on which the Docker daemon runs. Whatever you start it on top of the host's kernel. And from scratch means we don't have any operating system inside of our container. Okay, we don't need that one if we do from scratch. Yeah, we just copy it. We don't need that one if we do it from scratch. Everything else remains the same. So let me call the build again. Here it is. Okay, I did that also before. So it was quick again, and now let's take a look. And this is, I think, pretty impressive. Now we have a Docker image with 5.8 megabyte. This is essentially our application. This is the size of our executable. Compare that with a .NET Core package with a small microservice. Would be a little bit larger. If you do it on Windows, it would be even a little bit larger. Yeah, you probably will not do that because it's very useful to have an operating system like Alpine Linux inside of the Docker image, because maybe you need a shell to check something or do whatever Alpine gives you. So this is really just an experiment, but it shows you that it really is self-contained. You don't need anything more than the Linux kernel. It's just there. So let's build that back to what we had. Good. And let's rebuild it in order we can really run it. But it works. Yeah, you can start it and you can just trust me. It really works. Where is the Docker build? Here is the Docker build. Let's run it again. Now we have it in Alpine Linux. Good. Let's get it running. Docker run. What do we need? We need daemonized. We need a name. Let's say go web. We need a port mapping 80808080. That's fine. I'm just forwarding the port, and then we say start the image, go web. Good, it's running. And if my demo gods are smiling, I can now say localhost 8080 people, and we should receive a result. Yes, and this result is really coming from the Docker container, which now runs on my local machine. Okay, pretty fast to start up, pretty fast to work with. Let's kill it again. Docker rm-f d0d8, and it's gone. And just to prove the point, as soon, yeah, I will not get any response. So this was really the Docker container. Good. Now let's run this guy in Azure, for instance. Let's say Docker tag go web r Stropek go web. R Stropek is my handle on the Docker hub, and then we can say Docker push r Stropek go web. So we are pushing the image that we created before, and now it's on the Docker hub. Let's check that one. hub.docker.com. This is me, and here is the image that we created locally. Now it's on the Docker hub. Let's go into Azure. Here we are in Azure. I already created a resource group. Here it is. And let's add, you can now run this Docker image in any service that you like in Azure. Azure has, for instance, Azure App Service. It's a great service if you want to run a web app or a web API based on containers. If you want to have a fully blown Kubernetes server, use Azure Kubernetes Service, AKS. It's the managed Kubernetes run by Microsoft for you. It's the real Kubernetes that you maybe know and love, but you don't have to care for the Kubernetes server. That's a really nice thing. I would not be able to run Kubernetes on my own. I'm too much dev and too less ops, but I'm able to run my AKS. But there is even a simpler version. You can use so-called container instances. They are the simplest thing to run a container in Azure. It's really very simple. You just say, give me the name of the Docker image. Do you want to have a port open? Run it. And you pay for it based on CPU milliseconds and a CPU seconds, I think, and gigabyte memory working set. So you can really say, I need 4 processors with so and so many memory, or 2 processors with so and so many memory, and you pay by the second, by the gigabyte. So this works perfectly fine for short running things which run maybe only for a few seconds or a few minutes, maybe some data crunching stuff, creating a report, doing a data import. All these things work really, really nice with container instances. Of course, you can spin up these container instances from a Go program. Absolutely no problem. Okay, let's use that one. And the name of the container is, let's say, Go Web Live, to really see the difference. Of course, we run it in Europe, so let's take West Europe. It's a public image, and it's called our Stropek/Go Web. This is what we just said. And I can now choose the size of the memory and the CPUs. And because we have machine language and only a tiny image, we can really go down to a very small container instance and therefore save a lot of money. Good. Let's say networking. What do we need? I think we said we use port 8080, right? So let's say, yes, we need port 8080. That looks good. And let's say this is Go Web Live to have a DNS label. Anything else? Restart policy, I don't care. Tags, I don't care. Review and create. Yes, that's fine. Let's create it. Now, container instance is really, as I told you, the most agile way of starting up an image in Azure. You don't need any server, any app service. You don't need Kubernetes. You need nothing like that. With a single HTTP request, you can spin up such a container, do a little bit of work, pay for the few CPU seconds that you used, and terminate it again. This is what Azure Container Instances are all about.
Similar to a function? Or?
You could run functions inside of a container instance. It's more flexible. You don't need a specific programming model. You can run anything in such a container instance as long as it is a container.
Sure, but when do you use the container service and when do you use app service?
You use app service if you want something that runs for a longer time. It's not a good idea to run your corporate website in a container instance. It would be too expensive, and you are missing all the nice goodies that you get from Azure App Service in terms of load balancing and things like that. You cannot scale out this thing. You cannot say, give me 5 instances of that. Think of that, you run your web app in app services, and you scale your app services for the typical workload of your API or website. And then you have certain business processes, creating a large PDF report, importing a bunch of data from CSV. And you don't want to run that on your web servers because it would negatively influence the typical traffic on your web servers. With container instances, it gives you the flexibility to somehow let your base infrastructure breathe. You can say, okay, I need for only a few seconds a little bit of CPU. You can just outsource this task to a container instance and say, when you're done, do harakiri, kill yourself. So it generates the PDF, maybe sends out the message through an event grid, for instance, say, PDF is there, there's the URL, I'm now going to kill myself, done.
So is there only one instance or
No.
multiple instances of this?
Thousands if you want. Thousands if you want. If you run Kubernetes, for instance, in Azure, you can even set up ACI as a so-called virtual kubelet on Kubernetes. So whenever you schedule a pod in Kubernetes, for those of you who know Kubernetes, you know what I mean. If you schedule a pod in Kubernetes, you can tell Kubernetes to run the pod essentially in ACI. So you have, let's say, 5 VMs running your Kubernetes server, and then you have certain tasks that for which you need temporarily more power. Put them on the virtual kubelet, they will automatically spin up an ACI instance. You get additional compute power and memory, and when you're done, you immediately remove it again, and you pay by the second, by the gigabyte. It's just like electricity. It's no longer, as I always say, it's no longer reserving a hotel room where you pay for it even if you don't use it. It's really like electricity. If you need more power, schedule it, run it, kill it, and you only pay what you really use. That's the idea of ACI. Okay? And now I've used this service to spin up my machine, and we can take a look at it. Let's go here, copy it. Let's go here and say 8080 and people, And if we are lucky, we will get back something. Here it is. This is now our Go application based on Alpine Linux, the 17 megabytes or whatever, started in an ACI running in Azure, and we can do whatever we want. Running it in app service, exactly the same. Running it in Kubernetes, exactly the same. Run it locally on, I don't know, a Docker swarm, exactly the same. There is no difference.
So in this case, every time you refresh, you get a new instance?
No. Now my instance is running. My instance is running here. As you can see it here in the resource group that I created. Where did I create it? Here. This is my instance. It's a single core machine, only one machine, and this thing is running until I kill it. I will not stop it. I will really, once I'm done with this guy, I will really delete it. Now my instance is gone, and now I'm no longer paying. The most clear thing that I can show you is this button. Do you know this button, the Cloud Shell? Ever tried it? Guess what? Click on Cloud Shell. Oh, I need a bash. I need compute power for Rainer. Now, what could you do? Spin up an ACI, redirect standard out, standard in, standard error through WebSockets into your portal, and yeah, wait a few seconds. And if we wait another few seconds, come on, we'll get the bash, and it is an ACI. It could be an ACI. Maybe Microsoft is using some fancy stuff behind the scenes, but it is something like ACI, and now it's running for Rainer because he clicked on the Cloud Shell. If I'm idle for, let's say, 2 minutes, they will recognize it and kill the instance. And if thousands of people click on the same time on Cloud Shell, they will spin up a lot of instances that will go away once I close the browser or if I'm idle. Get the idea?
But they will see any instance inside of the Azure?
Absolutely, you will. You will probably not take a look at it. You will probably not care about it because you might have thousands of them.
So basically, like when you were running now this container, you
Yep.
were paying, but just for the computational power, basically.
No, for the CPUs that I assigned to this container instance.
For the CPUs.
Yeah.
Okay. So basically, okay. So it's not per how much.
So it's not like Azure Function where you pay only for the time you really use, but you also pay when the instance is running.
Yes. But you should not run it if you don't need it because it's so fast to spin up these instances. Get the idea?
So basically, in comparison to some Azure function or whatever, like there's basically you just define what it does and
Okay.
you get a return value, and here it's more like, okay, it's really running an instance of something.
Yes, something like Azure Functions could use, I'm not saying they are using it, but they could use the infrastructure of ACI in the background if they want. If you have load, they spin up an instance, and if the load drops down to 0, they can kill the instance. They could. The big misunderstanding here is what Azure Functions really is. Azure Functions is primarily a programming model. It's really a programming model like ASP.NET Core. It's a way of communicating and triggering algorithms. This is what Azure Functions mainly is. Of course, the programming model is designed in a way that they can spin up infrastructure just when they need it. So in the background, you don't have a web listener anymore. With Azure Functions, you are using gRPC in the background because the function's runtime will talk to your functions through gRPC, and then gRPC will schedule and trigger the function somehow internally. So Functions is really a programming model. It's not just resource allocation. Functions can run in app services without the consumption plan on a regular web server. And there you're just using the programming model. Okay, did you get the idea of ACI? Yeah, question.
At the moment, our container is not running. Huh?
No, it's not.
And how would they automatically start it and stop it?
You don't.
Okay.
You have to write code for that.
Okay.
You have, this is what I meant. Typically, if you run a web application, something like the Azure portal, you combine some other services like Kubernetes or app services, and inside of your application, you suddenly recognize, oh, I need to do something. And I don't want to do that on my web server because that would eaten up too much CPU power. Let's say you are creating a business report, a 600-page PDF. It will use a bunch of CPU, and if you render this PDF on your web servers, you have the noisy neighbor problem. You are eating too much CPU time. Of course, you can now auto-scale your web servers, but I don't need to. If I have something like that, rendering the PDF will take, let's say, 5 minutes. I don't care if spinning up the container instance takes 10 seconds. I really don't care. I spin up the container instance, render the PDF, write it to Blob Store, kill it. That's the idea of container instance. Get the idea? So maybe you learned also something about Azure. This is not related to Docker. You can run any kind of container, Windows and Linux. But in our case, and that's the beauty of Go, the Go container is small, it's tiny, it's fast, it's machine language, no just-in-time compilation, therefore it's starting even faster than a larger .NET application. Get the idea? Good. What else can I show you? Last but not least, my last demo that I've prepared, now that we have run this thing from scratch and Alpine and so on, I thought it would be fun to also build the Go file in Azure DevOps. So what I essentially did, let me show you that, I put everything on GitHub. And in GitHub, I have my simple web API here. It's available for you, you can take a look at it. And I created this WAML file. Are you familiar with Azure DevOps pipelines? Azure DevOps pipelines are essentially build automation where the automation script is a text file in your repository. So for this Go application, I added a pipeline. In Azure DevOps, here you see the Azure DevOps, I created a repository, and all you have to do in this repository in order to do building here is you say, yes, build, here is the WAML file done. It literally took me 15 clicks and my build automation was done because all I had to do is, this is the GitHub repository, this is the folder, yes, I agree, done. The first build was running. Now let's take a look at this build script. This build script is taking advantage of the fact that all modern Go versions, I think starting with Go 8 and 9 and 10 and 11 and 12, are installed on Microsoft build servers. So you can just use the build server that Microsoft provides, and for public GitHub repository it's free. You can use their build server and you can rely on the fact that they have installed Go on their build servers. So that's the important thing. It's only installed, as far as I can remember, on the Linux machines, not on the Windows machines. So you have to do some configuration on the Windows machines there. Then I'm setting up the Go environment. I will not go into the details here. It's a bunch of copying files around and setting some path variables. Just follow this link from the documentation and then you can copy this script from Microsoft. It's ready-made, you don't have to care about it, just run it and it will do all the necessary setup of the build server for every single build. Here comes the interesting part. The interesting part is it just works. You just say go get for installing any kind of dependencies that you need, in our case the Gorilla Mux. You just say go build in exactly the same way as we have seen locally and in the Docker file. Then you just use the copy file task. In my case, I'm copying the result. You see it? I'm calling it again web. So therefore, I'm copying the Linux executable into the artifact staging directory. This is the folder that stays alive after the build is done. And then I say publish build artifacts so that Azure DevOps will store the result of my build and make it available to me. So if I want, I can do a check-in. Did I change something? Not really. There is one untracked file, but we can remove this untracked file. We don't want to have it. I will just change anything. Yeah, here in my README, I will just say somewhere here, add an exclamation mark. I don't care. And then, let's check it in. So, where is it? Here is Go. And inside of the Go source and GitHub, and where is it? Our Stropek, here it is, and Golang samples, and go for it. Do git commit. Yes, here we are. I change anything. I can change the Go code. Any change of the GitHub repository is now important. Oh yeah. Enhance README. Good, push it. Now my Azure DevOps is configured for continuous integration. It monitors my GitHub repository and recognizes any changes that I do to the Go code. Well, in my case, for demo purposes, I just changed the README. Nevertheless, it triggers a build because I didn't filter for any kind of folders or extensions. So if we go here to the builds, in a few seconds, we should see that a new build comes up. Yeah, you see a new build. Build is running. Here it is. Let's click on it. We can take a look what this thing does. It's now, for those of you who are not familiar with Azure DevOps, it's now provisioning a new, fresh, plain VM, virtual machine, for building our application. And now it executes exactly the WAML file that you have seen before. So you see, it prepares the Go workspace. It installs the dependencies with go get. It now calls the go build. Come on, show me. Yes, this is exactly the go build statement that you have seen me running locally and inside of Docker. Okay. And we have some copy artifacts. And of course, I can run unit tests. Go test. Just add another element in the artifacts thing. And now we are done. Here in the artifacts folder, we can take a look at the drop location. And if I'm lucky, yes, I am lucky, here is my executable. From there on, I can do whatever I want. This is a Linux executable built in Azure DevOps on Microsoft's build agents. I don't need to prepare anything. The only thing that I have to provide is this WAML file. And the good thing is that Azure DevOps, as I mentioned before, has Go installed on their existing build servers, and therefore I can now take this executable. Let's do that as the last demo, okay? Let's download this thing. Oh, I already have downloaded it before. Of course, I tried this thing. I prepared. Let's call it Web2, for instance. Let's run locally a bash. This is just Ubuntu running on top of my Windows stuff. And say .web2. And this is now running a local version of the Go code compiled in Azure. And if everything works out nicely, I can say localhost 8080 people, and it will get a response. I will get a response. Yes, here it is. This is now the Linux executable built in Azure DevOps, copied onto my machine, running in Windows subsystem for Linux in my bash on top of my Windows kernel. So it's a little bit crazy. And I'm always, I can't believe that this stuff really works, but it really works. And the build was run in Azure DevOps. So this is what I wanted to show you to make it clear that the whole Go thing that I was talking for the first 1 hour or so works really nice in Azure and works really nice with Azure DevOps. So if you want to go into Azure and if you need tiny, efficient, memory efficient, CPU efficient microservices, Go might be an interesting option, or an option for a CLI, which can be a kind of alternative front end for your microservices, for instance. With that, I'm 4 minutes over my time, but we started 15 minutes late, so therefore I hope it was okay. I have a few minutes left for questions, but I think we should close the official part here. Unfortunately, I cannot stay for a long time because I have to catch a train. As I told you, I'm from Linz, so therefore I have to head home. So if you have questions, don't hesitate to come to me now in the next 5 or 10 minutes. Then I have to catch my scooter here in the back and rush to the train station to go home. I hope you enjoyed this 2 hours. You learned something new. You now have a clearer picture in your mind what Go is, what it isn't, why it is different from C# and TypeScript, and maybe you got curious and play a little bit with it. Here is the URL of my sample. I want to say thank you for inviting me, thank you for having me, and I wish you a very nice evening and enjoy food and drink and whatever is prepared for you. Thank you very much.